Let's talk about where this goes next. We mentioned a function earlier in this video that had a vertical tangent line, and I told you that that means the derivative doesn't exist at this point. But the question you might have, that might not have been as satisfying an answer for you right now, but the question you might have is, why does the derivative not exist at x equal to 0 for f of x equal to the cube root of x? When I graphed this, just kind of a free sketch of the parent function for cube root, I told you that as x approaches 0, what happens is that tangent line gets vertical, and that is kind of hard to visualize. And so one of the things that we're going to do, we said graphically, and you're kind of relying on me right now to tell you that, and maybe your imagination, if you can visualize this vertical tangent line. But graphically, it does in fact have a vertical tangent line there. But the next thing that we learn, in fact, the very next topic, 2.5, the next thing we learn we're going to learn some rules that allow us to take the derivative of that function easily. Right now, if I asked you to take the derivative of f of x, you would figure out how to try to make it work in the limit definition, and it would be really, really gross, especially because it's a cube root function. I'm going to show you in the next lesson how you can actually take this function and take its derivative in just a couple of very simple steps. And once you can do that, you'll get a better idea of why that derivative doesn't exist at x equals 0.